In this video, we're going to talk about similar triangles. So first, let's figure out what are similar triangles. They're triangles that have corresponding angles congruent and corresponding sides proportional. And I underlined the key words because those words are very important when you're trying to explain to me why two triangles are similar. So corresponding angles are congruent and corresponding sides are proportional. Well, proportional is when corresponding sides have the same ratio, and I'll show you how to do that on examples in a little bit. Another key thing we need to know is scale factor. So when you have similar triangles, they're all examples of a dilation, which means we're making one triangle bigger or smaller than the other triangle. So scale factors, we use them in dilations, which is what similar triangles are. And we get that scale factor from that ratio of corresponding sides. I don't care if you write it as a decimal or a reduced fraction. And again, we're going to do examples to show what that means. Now, before we get into examples, we have to know what the three theorems that we can use to prove two triangles are similar. The first theorem we can use is called the angle-angle theorem. We abbreviate it AA. And it states that if two angles in a triangle are congruent to two angles in another triangle, then the triangles are similar. Why? Well, because of triangle sum. So if all three angles are supposed to add up to 180 degrees in a triangle, we learned that in the past, then if we know two of the three, the third one is essentially fixed. So we know the third one will also have to be congruent. So since I have here 80 degrees, 80 degrees, 60 degrees, 60 degrees, I have two angles congruent to two angles in another triangle. So these would be similar by the angle-angle theorem. Now, something that you have to pay attention to is you're going to be asked to fill in what's called a similarity statement. So we're going to have to fill in the blank for this statement. So they'll start it off. So they named this triangle here. They named triangle BCA. Now, when I fill in this statement, I have to write it in the same order they wrote the first one, so that corresponding sides and angles are in the same location. So if I look here, B was written first. Well, B in this triangle is empty. There's no angle written there. Well, the angle that corresponds or matches over here is angle E. E has nothing written, so I have to write E first. Then they wrote angle C. Angle C is 80 degrees. Well, the angle that's 80 degrees in the other triangle is D, so that's the corresponding angle there, so that has to be second. Lastly, they wrote angle A, which is 60 degrees. Well, the 60-degree angle in this triangle is F. Okay, so we have to make sure that they are corresponding. So B and E go together. C and D go together. A and F go together. The order matters. You cannot write these in any order that you want. The next theorem is called the side-side-side theorem. And it says if three sides of a triangle are proportional to three sides of another triangle, then the triangles are similar. So this is where we'll learn how to tell if sides are proportional. You have to compare the corresponding sides and see if you get the same ratio every time. And you get the ratio by dividing those corresponding sides. So my method is that I find the largest side in the big triangle, in this case between 6, 7, and 4. 7 is the largest side. And then I find the largest side in the smaller triangle. In this case it was 3.5. And I'll divide them. 7 divided by 3.5, I get 2. So now I have to check and make sure the other corresponding sides will give me that same ratio of 2. And if they do, that means the sides are proportional. So the next biggest side is 6. And in the smaller triangle, the next biggest side is 3. So I would do 6 divided by 3. I also get 2. Lastly, I have to check the smallest side. So 4 is the smallest and 2 is the smallest. So 4 divided by 2 is also 2. So I compared the biggest sides, the next biggest sides, and the smallest sides to see if I get the same ratio. So since I got all of these to be the same, These are all the same ratio, which proves that the sides are proportional. So these are going to be similar triangles by the side theorem because it has all sides are proportional. Now, when we get to problems later on, it's going to ask you for the transformation. You're always going to state that the transformation is a dilation because one triangle is bigger or smaller than the other. It's going to ask you for a scale factor. The scale factor is this ratio, as we wrote on the front, the ratio of all the corresponding sides, so 2. So this larger triangle is twice as large as the smaller triangle. Now, when it comes to filling in the similarity statement, they named the first one JAC. So there's no angles, so we have to pay a little bit more attention. So JAC, so it went across the largest side, which I boxed in, and then across the smaller side, which I underlined. So I have to follow the same pattern here. The largest side was 3.5, which also had a box with it, and the smallest side was 2. So to follow the same pattern across the biggest side and then the smallest side, over here I have to do across the biggest side and then the smallest side. So it should be triangle OLM. The last theorem that we can use for similarity is the side angle side theorem. And it says if two sides of a triangle are proportional to two sides of another triangle and the included angle are congruent, then the triangles are similar. So we have to make sure we have two sides that are proportional and the included angle is congruent. So the angles are easy to check. 60 degrees, 60 degrees included between these sides. So that's easy to check. Now we have to check the sides. So similar to what we just did, I'm going to take the biggest side length here, 15, and the biggest side length here, which is 10, and try and see what that ratio is. So 15 divided by 10, I'm getting 1.5. So now I have to check if the smaller sides, when I compare those corresponding sides, if I get that same ratio. So I'm going to do 12 is the smallest here, and 8 is the smallest here. So 12 divided by 8, I also get 1.5. So because I got the same number, okay, so that's the same ratio, that tells me that the sides are proportional. So, as we stated before, when it asks for a transformation for all similar triangles, they're all examples of dilation because one is larger or smaller than the other. If it asks for a scale factor, you get that. That is the ratio that you got for both of these corresponding sides, so 1.5. All right, so the larger triangle is 1.5 times larger than the small. So now I have to name the second triangle. So they named the smaller one this time, so they did it PIT. So P is the angle that's 60 degrees. So I have to start in the same spot here. So the angle that's 60 degrees here is S. So I'm going to start with S. So then they went to I, and I went across the larger side of the triangle. Well, the larger side of the triangle, if I start at S, I'd have to go across here. So the next spot I would be is E, and then I'd end with L. So for PIT, I went across, started with 60 degrees, bigger side, blank side. Here, 60 degrees, bigger side, blank side. And that's why I got SEL. I'm going to do one example of each standard that you could be asked. So the first types of problems that you could be asked, the first standard deals with only the angle theorem. So the directions will ask you, are the following triangles similar by angle? If yes, explain why and complete the similarity statement. If no, explain why not. So first, I'm going to look at this example here. So there aren't any numbers for me to look at and compare. But they marked these angles with arcs. So here, angle C has 2 arcs in this triangle, and angle R has 2 in this one. So those are congruent to each other because they're marked the same. Here, angle B has 3 arcs, angle S has 3 arcs. They're marked the same, which means that they're congruent. So Angle-angle theorem stated we needed two corresponding angles to be congruent. We have that. So are they similar by angle-angle? Yes, they are, because they have at least two pairs of corresponding angles congruent. So now we have to fill in the similarity statement. So the first triangle they named CBA. CBA. So they went from the angle with 2 arcs, 3 arcs to blank. So I have to do the same thing here. Start with 2 arcs, which is R, 3 arcs, which is S, and the last one would be T. Another one that I want to show you is when I have a triangle inside of another triangle. So I have a smaller triangle and it's inside of a larger triangle. So I noticed that angle L and G are both 59 degrees. And then angle J, they wrote 53. But they only wrote 53 once, but you have to pay close attention because angle J is part of the smaller triangle. Angle J is in the smaller triangle, 53 degrees. But it's also part of the larger triangle, which is 53 degrees. So this angle J is in both triangles at the same time. So these are also an example that are similar by the angle-angle theorem because we have two pairs of corresponding angles congruent. 59 degrees, and 53 degrees is in both. So this angle, if you want to make a note, this angle is in both triangles at the same time. So that's where I'm seeing two pairs of corresponding angles. So yes, they are similar by AA because they have two pairs of corresponding angles congruent. So to fill in the similarity statement, triangle JKL, so they named the big one JKL. I'd have to name the second one JFG to follow the same pattern. The last one, I noticed that M and U, 88 degrees, 89 degrees. They're different. Even though it's only a degree, they're different. K is the same in both. But according to the theorem, you need two pairs of corresponding angles congruent. So since there's only one, no, these are not similar. Because it has only one corresponding angle congruent. If they're not similar, you do not fill out a similarity statement. That contradicts each other. You can't tell me they're not similar and then write into a similarity statement. So you leave it blank, you can put an X through it, whatever you need to do. The next standard that you would have to do is asking, are the following triangles similar or not? If they are, you have to answer all these questions: theorem, how you know, transformation, scale factor, and complete the statement. And if they're not, you have to explain why not. So I'm just going to do two examples of this one. So if I'm looking at this here, they give me 3 side lengths. So I have to determine if the sides are proportional. That's the key word. Sides have to be proportional for them to be similar. So the way I check is I find the biggest side on the big triangle, 84, and the biggest side on the smaller triangle, 14. And I'm going to find that ratio. So 84 over 14 gives me 6. So now I have to find the next largest. Well, the next largest side here is 72, and the next largest side here is 12. So 72 divided by 12, or over 12, is 6. Lastly, I have the smallest side is 48, the smallest side is 8. Well, 48 over 8 is also 6. I got the same ratio, the same number every single time when I compared my corresponding sides. So this tells me that the sides are proportional. So these triangles are similar. So it wants us to state the theorem. Well, they gave me 3 sides. They did not tell me any information on angles. So it has to be by the side, side, side theorem. Why? And again, I'm looking for the key words because all sides are proportional. That's the word I'm looking for, proportional. So the directions also want you to explain or state the transformation. All similar triangles are dilations. And it wants the scale factor. Well, the scale factor is the number you get when you get the ratio of all the sides. In this case, it is 6. The last thing we have to do is complete the similarity statement. So triangle CBA. So CBA, it went across the smallest side and then across the middle-sized side. In my markings on my paper, I underline and circle. So it goes across the underlined side and across the circle side. So I have to follow the same pattern here, across the underlined side and then across the circle side. So it'd be F, G, H. Another one I want to do. So if I'm looking here, I want to see if they're similar. I'm going to mark right away these vertical angles are congruent, because that's prior knowledge that we know. And now I want to find if the sides are proportional. So same pattern, I take the largest side in the big triangle and the largest side in the smaller triangle and find the ratio. So 49 divided by 14, I get 3.5. Smaller side over smaller side. 28 over 8, I got 3.5 again. I have the same ratio, so that means the sides are proportional. So yes, they're similar. This theorem would be side angle side because I have 2 sides proportional and included angles congruent. So yes, side angle side, because we have 2 corresponding sides proportional. And included angles congruent. It wants us to explain the transformation. Again, they're all dilations. And to get the scale factor, you look for the ratio. The ratio in this case was 3.5. The last thing we need to do is name the second triangle. So they named the first one VUT. So it went across the smallest side and then across the blank side. So here, I'm going to go across the smaller side and then across the blank side. So it'd be VL. The last one I want to show you is when they are not similar. So if I look at this one, I have to compare the corresponding sides. So I see the angles are congruent, 42, 42, so that's a good start, but I have to compare the corresponding sides. So here, 27 is the biggest side on this triangle, and both of these sides are 13, which should be a red flag, but let's pick a 13 and compare. So 27 divided by 13, that ratio is about 2.1 if you were to put it in the calculator. Now when I compare the next pair of sides, 24 and 13, so 24 over 13 is about 1.85. These are not the exact same number. Even if I rounded, I wouldn't get the number, but you don't even want to round. They have to be exactly the same. So since they're not the same, these are not similar triangles because the sides are not proportional.